Hello everyone, my name is Ahmad and today I'm going to be your lecturer for an introductory course about Introduction to Robotics with Coppeliasim. Um, so let's start right away. Okay, so what is our plan today? So in this video, basically, you're gonna learn about me. I will introduce myself as like the main lecturer for this course. And then I'm going to tell you the course outline in which we will follow during this course and or during this workshop. And then after that, we will have a very brief but informative introduction about robotics. And then after that, we will have a small interaction with a couple of examples about Coppeliasim. So first of all, who am I? My name is Ahmed Hamdan. I am a robotics engineer. Um, right now, I will start doing my master's degree in robotics as well. But all you need to know about me is that I am a person who is really curious and really passionate about robotics. I really spend a long portion of my life working with robots, participating in competitions, working on projects, and so on. Um, I have some experience which I'm willing to share with you during this course, experience with programming, experience with hardware, and so on. I'm curious about anything in life, mainly two things, problem solving and robotics, which involves a lot of things. It involves like working with hardware, control, machine learning, programming, and so on. So I really like challenging problems and I really like participating in competitions and so on. So what also is really a big part of my life is basically teaching. I really like the fact that I can share my knowledge with other people and help actually people who are trying uh, to start with something I really like robotics or programming. I really like guiding them, and I hope you're gonna see that during this course. So, why are we here? This is a big question. Basically, again, this is an introductory video for you, which I hope will motivate you to sign in for this course. But basically, this is basically what are we going to do during this course. So basically, we'll have a quick introduction about robotics in general. What are robotic systems, and what are the applications of them, and maybe with a couple of examples. And then after that, we will learn what are the main parts of robot systems. And when you are working on projects, hopefully in the future, when you start working on real projects, what are the important components of any robotic projects? So after that, we will learn how to program robots during this course, which is actually a big part of the work of robotic engineers right now. So programming robots is very important. We're going to do that during this course with Python, which is a very famous programming language. For those of you who do not know what is Python, it's absolutely fine. This course is basically designed for anyone who is like really interested and who's willing to put in the work to start from 0 point. So don't worry if you have zero experience with robotics or zero experience with programming. Don't worry, this is a very basic introductory course. We're going to start from like the level 0, but things are going to develop quickly. So even though we're starting from a very low level, we are trying to reach an intermediate level in understanding robotic systems, in understanding a little bit of control theory, and like the general broad vision of robotics engineering in general. Then after that, after we learn about programming, we will learn and test the knowledge that we learned on some projects in the simulation. Of course, the benefit of this simulator is that we don't need to spend money on it. In fact, thanks to Coppeliasim company and the people that running this company, if you are a student, then you have like a student license for it, and you can get all the functionalities of this software just because you are a student. Of course, it's not allowed to use it for commercial projects with your student license. But for now, actually, we're just learning, so this is going to benefit us a lot. So what's going to be the outline of this course mainly? So first, again, we're going to have a introduction about Coppeliasim, and at the same time, simultaneously, while we are learning about Coppeliasim, we will have a quick introduction, a parallel introduction about robotics. So you'll have a knowledge about robotics components and so on. After that, we're going to move quickly to Python programming. We're going to have a crash course about programming with Python. And mainly, we're going to tackle a bit of interesting problems like position and velocity control using Python. So that's going to be pretty interesting. And then after that, we're going to have a workshop. What is the workshop? Basically, the workshop is going to be, we're going to have a 3D model. We're going to have a 3D model of a specific robot. And then after that, we're going to import this robot and assemble it in Coppeliasim. People who have experience with 3D modeling will find this really interesting and very similar to what you do in any CAD system, basically, or computer-aided design systems. So we're going to import these files. We're going to assemble the robot in our simulator, which you will see in a minute. And then after that, we will start programming this robot, and also we'll add sensors to it. For example, we're going to make it follow a line. We're going to make it follow a wall or stay between two walls. We're going to apply some kind of simple controllers for it. So it's going to be really interesting. So you might want to stick for that. After that, we're going to learn some theoretical concepts about robotics and control. So we're going to learn what are the basics of robotics in general. So we're going to learn about robot manipulators, which are a very fancy and very useful kind of robots, which work in factories mainly. But now they are commercializing these robots, and they're applying a lot of new stuff. For example, in research, it's a really hot topic. They're like applying reinforcement learning and machine learning to these robots in order to allow them, for example, to play yo-yo or to play ping pong and so on. Also, we're going to learn a little bit about control. Very basic theory, and what is the goal of controlling, or how do we control robots using programming. And then after that, we're going to do some projects. These projects, again, are going to involve some robots, sensors, and programming. So what are the prerequisites for this course? We're going to have like a basic level of mathematics, high school mathematics mainly. So I'm pretty sure everybody who's going to enroll in this course are going to have this skill. Basic programming language. If you don't have a programming language, again, it's going to be fine. At the beginning, we'll start from point zero, but again, you're gonna you really have to be passionate about this course, because things are going to develop quickly. Of course, you will have time to learn and study, and of course, we'll give you all the guidance you need to start your journey with robotics and programming. But again, you need to also have the passion in order to grind through this starting phase, because the starting phase is going to be the most critical part for people who do not know programming. So once you take like 2 weeks in order to master the needed skills to continue this course, then you're going to be on the safe side. And then, of course, passion, because robotics is a very broad field, and even people who graduate from university may not have the required skill to enter to the industry. So basically, this course is not very similar to what you learn in school or what you learn in university. It's basically something a little bit different, something which we find useful in the industry. It's one of the important skills which you are required to have if you want to move to industry and or maybe to move to the competitive part of robotics. But again, it combines some theoretical knowledge which you will encounter in university if you study robotics, of course. So let's start our lecture, our main lecture, and of course, as any introductory course about robotics, we're going to ask the main question: what is a robot? Which might be a little bit controversial in some areas, but simply put, what is a robot? So there are like this is a recording, so we have no students at the moment attending this class live. So usually I ask this question and I like to hear answers from students. But for now I'm alone, so I will answer myself. But please, if you are watching this recording, you can maybe like pause this video and maybe think of a definition. So simply put, a robot is basically any kind of machine that is executing some kind of specific commands. Simply put, the robot should have some kind of hardware. So usually we do not consider, like in classical robotics, we do not consider, for example, chatbots or any kind of pure software. We do not consider it a robot. Yes, it represents some kind of consciousness for robots, but a robot, in the classical definition, it has to have some kind of hardware attached to the conscious part of it. So any kind of hardware or any kind of machine that is basically executing some kind of commands, we can think of it as a robot. So as you see over here, I put a photo of Tesla Cybertruck, and I'm pretty sure most of you have seen this truck before. Why do I put this photo while I'm defining robots? Because I think many of you already know, but this Tesla, or most of, or all basically Tesla cars have this autopilot mode in which the car can drive itself depending on the input that it's taking from several cameras distributed around the car. So in this case, we could consider this car as a robot. Why? Because it is basically executing some set of commands, and it contains some hardware, and it's basically taking its own decisions to drive itself with the people inside it. So I can truly see that this is a robot, and it's very similar to a robot that it's, for example, following a line, or a robot, a drone, which is basically again solving a maze by itself, and so on. So this is considered a robot. Another case or another example that you see over here is basically a hand, dexterous hand, robotic hand, which is holding a light bulb. And if you know, this kind of light bulb is basically very fragile. And if you press on it, maybe just slightly enough, it could break it. And I'm pretty sure we have robotic systems which are capable of holding this kind of light bulbs and actually screw them or unscrew them very gently without breaking them. And this is very very simple problem in robotics at the moment. So right now we're going to talk about components of any robotic systems in general. So we have basically five main components of any robotic system, which start with the brain, or in some cases, basically, it could be the CPU or the GPU that is running this robot. It does all kind of computations. It takes all decisions, and all other parts basically depend on this part, in which represent the consciousness of a robot. Okay, actuators, which receive its commands to move from the brain itself, or from the controller. And they are, of course, responsible for moving the robot around, interacting for the robot to interact with the environment and so on. Also sensors. We can think of sensors as the window that the robot perceives the surrounding environment from. So the only way that the robot can sense the environment around it is basically through these sensors. And of course, we will have, if we have like some kind of autonomous system, usually the robot take feedback from the sensors. It perceives the surrounding environment and sends these data to the brain, or basically to the processor. And this processor has some kind of code which will be understanding this data that came from the sensors, and then after that it will act on this data and do whatever suitable for this case, and send commands to the actuators, of course, to execute. After that, we have the body. Bodies are actually very, it could vary from like very simple metallic sheet which connected to the robot, or it could be a very advanced high carbon, or maybe a new material that is constructed, that constructs a robot. So this vary, and but mainly we use metal for industrial robotics, or plastic, it depends. Power supply, of course, we use electricity for robots, and we could have either batteries, or we could plug it into like into a socket or so on. So these are the 5 main components of any robotic system, and these are like very general, of course. Any robotic system will have these 3 main components, but of course they vary. Again, for example, for the body, we could have a metal, we could have a plastic sheet, or we could have carbon, I don't know, any kind of interesting material that we have at the moment. Probably people who work with chemistry, they have made a lot of new material at the moment. So why this course specifically? One could ask, why do we learn how to control robots in simulation, while in real life we will need to control robots, like the real hardware of robots? Therefore, I put this example for you. This is a robot in which I was, like right now I'm working on it. It's called Kuka-Iwa LBR, and it's a 7 degrees of freedom robot. What do we mean by 6 degrees of freedom? We mean that it has 7 degrees of freedom. It has 7 motors, 7 joints, 7 actuated joints, in which, for example, it can rotate around this joint, it can rotate around this joint, and so on. So basically, it has 7 joints which are capable to move this robot. So that's why we call it 7 degrees of freedom. So I worked in this robot, and this robot costs, like the baseline, the minimum price of this robot with its lowest functionalities, it will cost around $100,000. And if you are a robotics engineer, you will definitely, like during your university, you will definitely not have access to such hardware. Therefore, people practice in simulation. Here, you see, we can import, for example, in my lab, we have only this robot. We have like 3 of this robot only, 3 versions, and we can control all of them. But for example, in one project, I needed to work on another type of robot, which is called a universal robot. And we didn't have it. So I had to work in simulation. And that's what you're going to do in your academic life, probably, unless you are like super lucky, you will not have access to such full hardware, unfortunately, because it's very expensive. And that's why you will need to work in simulation. What is cool about simulation is that in simulators, People worked really hard in order to simulate the physical environment. So this simulator, for example, this is a screenshot taken from Coppeliasim, and this Coppeliasim simulator has a physics engine, so it can basically simulate the reaction forces. It can simulate if you touch an object, it will move, for example, depending on its mass. It has gravity, all these um, almost real life experiments could be applied in this simulator to some extent, of course. Of course, in life will be a little bit different, but for experiments, even in industry, we use such simulators. Why? Again, it's cheaper, and again, it's not always safe to test immediately on hardware. So even if you work on in the industry and you have this kind of robot over here, you will still need to test your code and your program in simulation to avoid any kind of unneeded collision or any kind of mistakes. Because again, if you make a mistake, it will cost maybe your company around ten to $20,000 at least to fix it. And it may take like 1 or 2 months. So you will not gonna risk that, of course. So what do we get from Coppeliasim? We get free robots. So we have a library in which we will introduce in a minute for Coppeliasim, and it has tons of robots. Definitely no lab in the world, no company in the world has the amount of robots that are available in Coppeliasim. So this is a huge plus. You can basically work on any robot you want. Even if the robot is not available in Coppeliasim, you can actually draw your own robot on any CAD system and basically import it into your simulator over here. And we will probably do that in this course. Um, so you will have a custom made robot and import it to your simulator and work with it. So it's a very huge opportunity, and nobody can actually miss this opportunity. Free environment, again, if you are a student, basically you're going to get all these functionalities, all these free robots, all these possible experiments, and you will be able to do them in this simulator. Free sensors, not only robots, you could actually add sensors, for example. So you see this robot over here, I can add to it a force sensor at the end, for example, or I can add to it a camera at the end with a gripper and attach them together in the simulator. And the simulator will understand now this is a new robot. And again, sensors are also super expensive in some cases, some of them, and you can have all that for free. And there you can program these sensors and get data from these sensors during the work that you do in this simulator. Again, risk-free experiments. So we use this simulator, not only this simulator, any kind of simulation, we use them to assess the risk that we're going to do in any experiment. So we test our code in the simulator. We make sure that it works in all cases. We minimize the risk to the lowest percentage possible, and then the same code could be taken and applied to the hardware. That's what we do basically. The same code that you write in this simulator over here, you will be able to take it as it is and apply it to the hardware immediately. So now it is time to introduce the Coppelia simulator on my laptop. Let me just open it. 1 second. Okay. So here we are at Coppeliasim main interface. And basically, as you see here, we have basically the main floor of the game or of the scene, basically the one that we have over here. And mainly you have these horizontal set of commands that you can use, and you have over here the main vertical set of commands that we're going to use. Mainly, we're going to explain each one of them one by one. So the first one basically, well, first let me insert a cuboid, let's say. Let's put it in the center for now. And basically, here we are. So the way we move around in the scene is actually over here. So the first one, if we pick the first option, is basically we move around. We drag. You see over here, we drag like this. So I want to go here, here, and so on. For example, in the second method of moving is rotating. So we rotate like this. It's possible to rotate. As you see, I can zoom in using the wheel if you're using a mouse, or like uh, uh, the same convenient form if you're like using a touchpad or so. Over here we have zooming in and zooming out, this method over here. So I could actually zoom out or zoom in using without using the wheel, using the mouse, the left click on the mouse. So over here, as you see. So basically what could also be possible, we could focus on one object. So if I press over here, so let's say I am like this over here. Let's say. And I want to focus on the cuboid that I have over here. So I can immediately press on fit to view. And the object that I selected over here is going to be the main object in the new view. So I can press like this. And as you see now, I just zoomed in immediately to this specific object, and the new screen has fitted exactly to fit this new object over here that I selected over here. So what else can we can do? Basically, here you have the model browser, which is nothing but a library to show all the possible robots, or not only robots actually, all the possible objects that we can insert into this scene over here. So what could be an interesting example actually? For example, let me well, let's see them one by one. So the most interesting one will be robots for us at the moment. So we have a folder full of robots. So we have mobile robots and non-mobile robots. By mobile robots, all the robots that can move, not only with wheels, it could be with drones, it could be like this one, for example, like a snake. Let's take a look at them one by one. So mobile robots, over here we have this robot which can move like a snake. We have this hexapod. We have, I think this is Asimo. No, this is like very similar to Asimo, the robot by Honda, humanoid robot. We have this ball robot which actually balances on a ball and it can move around. We have the R12, we have the R20, we have this hexapod again, like a different form. We have, what else do we have? Okay, let's see. Oh, we have, this is widely used in Kuka factories. We have Kuka Robot, line follower. This, we could use it actually later to do some experiments with it. We have now very famous robot, drones, some wheeled robots, and so on. To, let's see, non-mobile robots, we have a lot of manipulators based robots. So why do we call them non-mobile? Because these robots are actually stationary robots. We install them in research centers, we install them also in factories and so on. So they are widely helpful. For example, this is Abe robot. Also have, actually I'm gonna add the robot that I use usually, UR, Kuka UI UR. So I will place it somewhere over here, and as you see, like the cuboid is very small, while this Kuka over here is a little bit wider. So let's fit. So you see, I fitted the scene just to show only the Kuka. We can actually, I will add another manipulator. Let's say, for example, UR5. I will just add it next to it over here. Okay, and what I said earlier about the simulator is that Being a simulator, that means it needs to simulate a lot of things. One of them is movement, one of them is collision, gravity, and all these physical concepts that we have. So let's say I program a robot. Each one of these robots actually has a default movement. Of course, we can change it, but whenever you import this model, any robot in your code or in your scene over here, it has just like a default movement to show. So let's say if I run simulate or start simulation, we will see this default movement being executed on these two arms over here. So I will run, and as you see, each one of them is doing a specific movement, and this is the movement that actually the default movement that they have. So let me stop over here. What could be possible also, we could show some different view angles, as you see over here. So I could choose any camera of these. For example, this is a camera, but also it might not be helpful. This is front view. This is also front view, but from a different angle. I can run also simulation from here. So as you see, both arms, each one of them is moving with a different movement. So don't really pay attention to the movement for now. It's just normal movement, default movement. So as you see here, we have the scene hierarchy. All the objects that has been imported into the scene, you can see them over here. And what is interesting is that you can see all the components of each robot. So basically, let's say that we have UR5 over here. UR5 is this blue manipulator over here. I will change the scene a little bit so you can actually get a better intuition of what's happening. So, sorry. Yeah. So this is the UR. And as you see, we have link, joint, link, joint, link, joint, and so on. So all these components, so each joint and each link has been modeled specifically or independently, and then all these objects has been connected together. The same way we do with any CAD system. You start building your robot or your the thing that you're gonna print or your model step by step, and then you join everything together. And that's here what's happening. Um, you're adding each link, each joint, and you see each one of them. So you can fold this. Also the same thing for Kuka Iwa. This is LBR Iwa 7R800. Also, you can see all the joints and links connected to it. Okay, so also what we can do, let's add one mobile robot over here. Let's say this one. Okay, and let's run the simulation. Let's see if it, you see it's moving around. This is the default movement for it. Let's see where does it go. It falls. You see we have like specific floor, and you see there's a gravity. So if it goes on the edge, it will fall. I will show you again so you can actually get a better understanding for what's going on. So here it is. Then we'll run simulation again. And as you see the robot over here moving, and it will reach the end of this floor and oops, it fell down. And that's what I'm talking about. This is the gravity simulation. And as you see, it's very interesting dynamics happening over here. You could say almost it's like very real. Here you specify the physics engine that you're gonna use. We're using like the bullet engine. There are like several other types of um, physics simulators, but for now we're gonna stick with this one, the bullet engine, the standard one. What also could happen also, we could actually add a human being over here, people. And our friend, we have Bill. So I'm gonna add Bill to the scene. And let's make him walk around. So Bill is walking around. As you see, he's walking. Everybody is moving, and the robot is falling. And then Bill will follow this path as you see over here. Interesting. So if we have any object in front of Bill, something wrong is going to happen. Bill is going to hit this object. So let me add a cuboid, or maybe actually I can add another robot, or let's say furniture chair. I will put it over here. And let's run the simulation one more time. This one, okay, this one doesn't have a physics. Okay, no problem. So, okay. So, what we can do also basically here, well, if we want Bill to hit this one, to hit this object specifically, we need to define some physics for it. So you can define an object to be transparent, you can define other objects to be non-transparent. So this one seems to be by default transparent, but this is not a problem. What else we can do? So for example, let's say I want to move this object around. Let's say I want to move this chair around. So as you see here, I can basically change the position of this object just by clicking on this icon over here, and I can move it around, as you see over here. And also I can move it on all axes. So for example, on which axis I want to move it. Let's say I want to move it on the x-axis only. Now I'm allowed to move it only on the x-axis. Let's say I want to move it vertically only. I want to move it on the z-axis. So as you see here now, I restricted the movement to be allowed only on the z-axis at the moment. And let's say I want to put it over here. Okay. Now I want to move it on the y-axis, which is going to be like this. Even like if I move the mouse wherever, I can only move it on the y-axis. All right. So as you see over here, we just imported a couple of examples, and basically we run the simulation. We showed a couple of robots, but basically this is just a quick introduction for what we are capable of doing in this simulator over here. I will go to the final slide, so give me a second. What was the plan for today, or what we achieved today? So in this quick video, we learned a little bit the general idea of robotics. We defined what is a robot, and we defined what are the main components of any robotic system. So in overall, it was just a general overview of the world of robotics, and then after that, we learned a little bit about the applications of Coppeliasim. So how to do risk-free experiments, how to assess our code, and so on, and how to avoid paying large bills on very expensive hardware. And then after that, we just had a quick tour in Coppeliasim simulator. We imported some robots from the library. We run the default simulation that they have in their code, and we just had just simple, brief examples about that. So if you reach till the point of this video, I want to thank you very much for your patience, and I really hope to see you all, anybody who's watching this video, I really hope to see you all in the course that we're going to be providing. And I hope to see you soon. I promise you we will have very interesting examples, very interesting tasks. And I really hope that you will benefit a lot from this course. So thank you very much. to spending the time in this video. And I really hope to see you in our course. Have a good day for all of you, and stay safe. Bye bye.